and that force of interest is variable during a period. When I talk about a force of interest is constant during a period, probably we can say we have looked at the accumulated value is nothing but accumulation factor is e power delta t, where t is the time period of investment, or the present value factor, whatever is our amount, S naught into e power delta t is the accumulated value, whereas the present value is st into e power minus delta t. So when the force of interest was given, but that force of interest was constant, the present value came out to be the future value into e power minus delta t, and at the same time the future value or the accumulated value came out to S naught into e power delta t. That was quite simple and straightforward when the force of interest was more or less constant. But if it is variable, what I mean by variable is, if you see that this delta is probably following some specific rule, let's say delta 1 between 0 to t1 some time period, or probably delta 2 some other formula where let's say it is between t1 and t2, like that, probably some delta 3 if it is between t3 and t4, and probably delta 4 probably when it is greater than t4. So like this, what could happen is, instead of the interest rate remaining constant during the period, if I see that the interest rate is variable during a particular period, all I would like to look out for is, when I want to find out the integrated, the accumulation factor. See, for us the accumulation factor is like e power delta. So when I want an accumulation factor, I'll take it as e power delta. When I want a present value factor, I'll take it as e power minus delta. So straightforward, e power delta. So because it is continuous in this entire period, in the e power, what I'll do is, okay, e power 0 to t1, I'll say delta 1s ds. I integrate this between 0 to t1. Then similarly at the power layer itself, I'll put all the one. Okay, between t1 to t2, I'll do it as delta 2s ds. Again in the same power between t2 to 3, I'll say delta 3s ds. And finally, let's say I'll look out for t3 to t, delta 4 SDS, especially if I'm looking at a t which is greater than t4, a t which is greater than t4. If I'm looking at a t which is greater than t4, I'll use this entire formula to obtain the multiplication to obtain the accumulation factor of a cash flow, and I'll use minus delta across to get the present value factor. Now with the same example, let's say I want to know what would be the accumulation factor. Probably if t is lying between this one, t is lying between t1 and t. So again, only those two terms will be used, 0 to t1, delta 1s, and here I will take t1 to only t. I will not go to t2 because t1 is lying somewhere in that group only. So this itself will be my accumulation value. Similarly, when I put minus, this will become my present value. So you should be comfortable in terms of doing the integrations for these things. Otherwise, conceptually, this is the way we try to arrive at the accumulated value of a cash flow, so these are more applicable for single cash flows. Lump sum cash flow, either finding out the accumulated value after a certain point in time, or based on the accumulated value of future, trying to find out the present value associated with it. So that is how we try to find out, depending on where that t is lying and between what interval. So from 0 till that point t, whatever are the intermediate intervals that are there where the deltas are changing, all those are integrated separately for those entire period and then simplified. That is what is the way we compute the present value as well as accumulated value of one single cash flow. Right, once we practice a few numericals regarding the same, you will get a very good comfort level regarding the usages of this integration. But of course, the one thing that is expected is you should be quite comfortable with the usage of the various rules of integration and then get into the calculation processes quite comfortably. But in this case, the other important concept which I would like to drive is, apart from the single cash flows, we are also talking about a continuous stream of cash flows. So these are two important items that I am looking at. When I am talking about a single cash flow, we have already seen to find out the accumulated value, we have said e power integral 0 to t delta s ds. And for the present value, we have taken it as e power minus integral 0 to t delta s ds. But when the cash flow, so sometimes it is said that a cash flow, right? We are not talking about one single cash flow. We are talking about a stream of cash flows between a particular period. Let's say A and B. So there is a stream of cash flow between A and B, and during that period we are seeing a variable interest rate delta t. If that is the case, what is the way we look out for the present value as well as for the future value? Straightforward. So instead of one, so for the delta t, the concept is still the same. So if I am watching for the present value, I will look out for integral of minus a to t, because at t, from t I am trying to get the value of from a till t, I am trying to discount this, probably the ds, delta s ds, and of course, so this entire amount, instead of multiplying it with one single constant, we are talking about a constant stream of cash flows. So whatever, let's say I am talking about this as rho of t, this I will multiply it with this force of interest at dt. The same logic if I am talking about a future value from t till b, again the same delta s ds. This is nothing but, this is the way we are talking about the force of interest. And now there is a cash flow which is between A and B, rho of t, and this is multiplied by dt. So this is how we find out the accumulated value when we have a continuous stream of cash flows. This is how we find out the present value when we have a continuous stream of cash flows. So using these two logics, we should be able to find out the present values and accumulated values of a stream of cash flows, where when the force of interest is given and that force of interest is variable, right? And now we'll take up the examples relating to all these four aspects: a single stream, a single cash flows when the variable interest rate is given, finding out the present value as well as the accumulated value of that. Then also I am looking at a stream of cash flows where which are being paid between A and B period, and I am looking at a variable interest rate operating during that particular period, trying to find out the present value as well as the accumulated value. We'll take up the numericals on all these aspects and then try to understand how we use the integration effectively to compute the accumulated value as well as the present value in these cases. Alright, so let's get started into the numericals on this front. Now let's look at the computation of the present value of a series of payments which are increasing by a certain rate for certain period. So I can use the basic fundamentals itself to try finding out the present value. So we can just see a series of 10 payments is received starting from the 7th year onwards. So we are at 0 up to 7 years, no payment. In the 7th year we are receiving a payment. The first payment is 2064 rupees. Each of the next payments is 7.28% greater than the previous one. So 2064 into 1 plus 7.28%. The next again 2064 into 1 plus 7.28% squared. Similarly, one more year 2064 into 1 plus 7.28% cube, and finally